Hello, in this video, I'm going to demonstrate how CINEMAS uses a program called Robocrystallographer. Now, Robocrystallographer is an otherwise command line based program which is used to describe a given structure in a text format. Now, the structure can be in any format like POSCAR, it can be in .vas format, it can be in CIF format or XSF format. Robocrystallographer belongs to PyMedGen family, and we have integrated it into CINEMAS through a graphical user interface. So let's see how does it work within CINEMAS. So I'm assuming a case where I'm having multiple structures loaded into CINEMAS. Now let's go to visualizer. I can see that strontium titanate POSCAR is here. I can see that there are 3 other tabs also open. So multiple structures are open. So now whichever tab is active, let's invoke the Robocrystallographer program through this icon. One window is open. Now you can see that there are so many options which I'm going to explain in a few moments. So now let's see how does it describe a given structure, which in our case is strontium titanate, and let's see with basic options how does it work. So I'm going to click run. Now depending upon your machine's specifications, this is going to take few moments. The original program itself takes a while to give you the text description. Okay, so now you can see that this has come out. Now this describes the formula. Now this program also gives you the mineral name. This gives you the space group. The description also tells you the symmetry levels. It also tells you the bond length descriptions and etc. Now let's compare these options. So you can see that right now the description is given in a Unicode format. However, there are options of HTML format, LaTeX format, and the raw format are also available. Now let's see how does the LaTeX format works. For a comparison, I'm going to open one more window, and this time I'm going to run it in a LaTeX mode. Let me click run. Again, how powerful your machine is, the execution time is dependent on that. Okay, so you can see that the execution is over. Now let's compare. Now you can see the difference between the text formats. Here it's angstrom sign, while here it is replaced by here it is replaced by its LaTeX equivalent. Also you can see there are superscripts for, you can see there are the 2 minus has been replaced with its LaTeX equivalent. Now let's see how does the HTML option work. Okay, so now HTML execution is also over, and you can see that now all the superscripts and other things have been replaced with their HTML equivalent, and this is how a HTML output looks like. Now let's have a look at what are all these options. So these options are self-explanatory. Let me choose ones which can show you a quick difference. So here you can see that the bond lengths are described in 2 decimal point. And by the way, this is my my example strontium titanate structure. I have created it with my hypothetical lattice parameters. That's why you are seeing it as 2.00. Otherwise it will be something else if I take the actual lattice parameter. So this is just for the test purpose. Now you can see that the decimal places for bond lengths, the default is 2 decimal places. That's why you are seeing 0 0 or you are seeing 8 3. So let's increase it to 4. Now you can see that it is telling you, you can see 1 within brackets, precision also you can see, for titanium also you can see. Now what is this? These are symmetry levels. Now what you can do is, let's switch it off, and then for a comparison, oh by the way, for a comparison let me run the same thing in a new window. These options work only when you press run button. For a comparison, what I'm going to do is I'm going to switch off symmetry levels and Unicode, and I'm going to increase the decimal places for the bond length description. Now let me see how it is going to affect the text description. Okay, so this execution is over. Now you can see that the bond lengths are described in 4 decimal places now, and also you can see that these labels, symmetry labels, are also disappeared now because we switched off this option. Similarly, you can play around with these options, and the description of these options can be found on web page from the developers of this program. Alright, so here I showed you an example of this program within the same tab. Now let's say I executed a Robocryst description for a tab containing strontium titanate. Now let's see how does it work if I switch to a different tab. Let me execute it again. Okay, so now you can see this execution is over, and now the description is coming from description has come for CSPB i3, which is a different tab. Now coming back to this window, now these buttons are self-explanatory. Run executes the program, reset switches back all these options to their default. Now let's say you chose your own options and you would like to use them again without making a choice again. You can set all these options as per your, you can set all these options as you desire, and if you want to remove all these custom defaults, you can switch it back to CINEMA's original options. So to conclude, I have shown you how Robocryst's program works within CINEMA's for different formats with different options, and also how it works switching tabs. Thank you so much for your attention.